Hello everyone, welcome to my talk. Today I'll be talking about a DataFrame library named FireDucks that we are working at the research lab. So we will explore the motivation behind developing the FireDucks by stating some of the key challenges with Pandas. And of course, we'll be talking about the tips and tricks and the best practices when dealing with large-scale data processing in Pandas, what FireDucks is and what it is offering, the optimization strategy available with it, with some live demo and the resources available on FireDucks. So let's have a quick introduction. My name is Sourav. I'm currently working as a research engineer at NEC Corporation. So I have been associated with NEC over the last 11 years, where I'm doing different work in the field of high performance computing, distributed processing, AI, machine learning related stuff. So we have a long history of working with vector supercomputer, where we start with A6 series of supercomputer and work with many various legacy application from tsunami prediction to earthquake simulations on this vector architecture. My leader one at my team, Mr. Saha, first thought that we including our expertise in the field of HPC and the compiler and this kind of distributed processing related task. How about creating something that will use the compiler techniques, because we have a keen interest in compiler, and at the same time do something with the Python for the data science community. So that is the time when you thought, okay, data scientists often face challenges with the Pandas computation. So let's create some library that will look completely same as Pandas, but internally it will have a compiler and do a lot of magic kind of stuff, such that a programmer, a Pandas programmer can experience much faster data processing when using FireDucks. So please stay with me till the end of this presentation, where I'll be talking about various best practices. I will give you a walkthrough with the FireDucks, the offering, the motivation, the comparison with other DataFrame libraries that is available. And of course, at the end, I'll have some frequently asked questions, because this is something online. So, and of course, if you have any questions, you can get in touch with me over the LinkedIn or other social media. I'll be happy to collaborate and help you in whatever matter I can. Yes. So this is the flow I believe all of you can relate. What we do as a data scientist, we collect data from various resources, and the data in the raw format is not readily digestible by the AI machine learning algorithm. So what we do is we clean the data, make it more meaningful so that we can get the better features out of it and we can do a better model. So better the data is the better the model. That is some kind of old story that we have been learned about. But the important thing for this entire cycle to understand that although AI machine learning is taking time and deploying model is also taking time, but the most time consuming part is the creation of the data as per the research from the Anaconda. It says that the data loading, cleaning and the visualization is something that occupies almost 75% the effort of a data scientist. So if you have a lot of questions in mind, if you want to extract a lot of many features, you need to spend a lot of time in during the first few months, I would say, for doing the efficient data exploration. So that is why various researches has been happening in this field, because this is one of the most important areas where we need optimization. Now with this, let me have something about Pandas. I believe all of you are from the data science background, so you must have worked with Pandas. So it is one of the most popular libraries. Even today, it is having the second most download after NumPy, but it comes with some kind of problems. The very common one is it's not multi-threaded. So if you have a good system with many core available, you cannot be able to leverage that. So your program will be slow. You have to wait for a longer time to get your result if you are working with the large data. So longer waiting time, slow execution if you're running this on the cloud side, a higher cloud cost, and of course the longer execution will attribute a lot of carbon dioxide. So these are something that is associated with Pandas. So it is ideally not ideal for the large scale execution, right? So now, although these are the challenges associated with Pandas, but the key challenge is like there are various way of writing the same program in Pandas. So if we ourselves can identify the best approaches, the best practices and take care of that when writing our program, it's fine enough. because by default Pandas doesn't offer you optimization as it is eager in nature. So whatever you ask it to do, it will do it for you. So if you have written a good code, an optimized one, yet you are at good states. But if your program has performance issue, you may need to pay a lot of performance cost when your data grows in size or your program grows in complexity. So we're talking about some crucial performance issue that involves in a Pandas program and how to take care of that and what are the automation possibility for those cases using FireDucks and other library. So to going forward, let us understand one by one the best practices and challenges associated with large scale data analysis program. So with that, let us have a first quiz. Can you identify which one is a better code, whether the left one or the right one? Yeah, since I'm doing this online, so definitely cannot take the response from you. But when I asked this kind of question in one of the event last time, so I believe I had mostly around 90% of them answered the rightmost one is the best performing query because of many reasons. So as you can see, this is written in chain, and that is ideally the best way of writing this kind of query in Pandas or Pandas like library. Why? Let's understand that with some kind of illustration. So let's say this is the data that I have loaded from file. Of course, you can see there are some duplicates. Once I remove the duplicate, this will be the data. My data might be reduced to its half. Then I'll be sorting the result by B column, selecting the top two of the result, and that's it. Now let's assume some kind of memory footprint associated with the data. Let's say my data is 16 GB. After the removing duplicate, it will be 8 GB, 8 GB, and some other GB. So at the end of the thing, it will be 32 GB. But till the time the foo is alive, all these references like df2, t3 are alive because pandas, not pandas, Python cannot make them ready for the garbage collection because they have the reference alive in the alive, right? So that is the challenge with not writing the chained expression. What happens when you go for the chained expression? It will be like the data is loaded, we remove the duplicates, but now when we'll be applying the sorting, at that moment, I only need the input from the drop duplicate side. So I don't need this data anymore. So this data will be out of reference and Python can make it garbage collected based on its need. So the same way when I will perform the top two, I don't need the duplicated result, drop duplicates result. I only need the shorter result. So this way at the end of my program, I can remove the intermediate data that is there, that is generated during my query of the long expression. So, and that is definitely going to help you when you'll be dealing with large scale data. I'll be showing this kind of thing with example in my upcoming slides. So that is one of the best practices, that write your expression in chained expression, and it is possible in pandas. Of course it's possible. So as much as possible, try to go for the chained expression such that you can avoid this kind of memory and performance issues. Now let's consider the second one. So here is a quiz. It is trying to solve the same problem. It is trying to find the top 5 of A value based on the sorting from the B column, right? Now can you guess which one is a better code if you're about to write the code, whether you'll go for the top one or you'll go for the bottom one? Yeah, so when I asked this kind of question in a recent event, so almost I have mixed answer. So 40 to 50% answer that the top one is the good one, and 50 to 60% answer that the bottom one is the good one. So with the majority, the answer is of course the bottom one. So if you yourself thought it is the bottom one, yeah, give a pat on your back. Now let's understand why it is so. What happens ideally, your data may have many columns in reality, right? Not only A and B. If you are going to perform the sorting on the entire data, what will happen? Not only the target columns A and B, rest of the column like C to J will get sorted, and that will never be used in your final result because you're only interested to have the sorted value from the A column after the result is sorted by B. So the C to G column will get sorted based on the B columns. It will occupy the memory, but it will no longer be needed. So it is waste of computation time and memory. So what you can do, you can create a view of the data of my interest that I'm interested in A and B column only. So why not just create a view of that data, perform the same steps, do the same thing, And this will definitely going to reduce a lot of computation cost, because it doesn't matter how many column your data may have, because you also understand I am interested in A and B. So let's not bother about rest of the column. Let's create a view and work on that. This kind of optimization is something called projection push down, and it is very important that we should take care when dealing with large scale data analysis. Now let's consider another example. So before going to the quiz, let me show what it is trying to do. For example, I have an employee table and a control table, and I want to perform some kind of merging to have a larger joint result and see who are the male employees from which country, like how many, like country wise count of the male employee is something of my problem. So how it can be done? One thing that I can just join these two tables, then I can filter all the male category from the resulting data, and I can perform a group by count. So by looking at this illustration, can you identify what is the performance bottleneck? Yes. The issue is with the expensive merge operation. So although we are only interested in the male category employee, what we did is we performed the merging on the entire employee table. We could instead do what? We could first filter only the male category from my employee table, and then we can do the merging operation followed by the group by count. It will do a lot of benefit when you have like kind of 50-50% of the employee ratio, or you have very less amount of male like employees, because it can reduce the data by to a great extent, and the merge will not take much time in that case. So this is something called predicate push down in terms of compiler technology. So again, this is one of the very important optimization strategy. We should ideally take care of that, and we'll see with some demo that how this kind of strategy is important when dealing with large scale data analysis in upcoming slides. So now let's put these two in some kind of like rule of thumb. So again, in order to understand that the importance of such execution order, let's take this example where it is trying to perform sorting by the E column, do the filtration based on some condition in B column, select the E column and get the top two. Now, in order to illustrate that, let's consider this is my data. And if I sort the data with this color code, I will have the sorted result from the yellow, red, green, and blue. This is my data after I sort it. Something like yellow, red, green, and blue will be result. Let's consider B equals to 1 for the darker shade and B equals to 1, 2 for the lighter shade. So if I filter, I will only have the lighter shaded part. Then I will select the only E column and find the top two. Now, if we carefully notice this entire data flow, can you identify what is wrong in this journey? Of course you can, right? You can say that although I'm interested in only A, B and E columns, I have already involved rest of the columns like C and D that is there in my data that have been used but never referenced. So that is ideally in waste of memory and computation time. So instead what we can do is we can first identify that for this query I only need A, B and E column. So why not just create a view of A, B, E column such that we can reduce my scope of the data first in the horizontal direction by applying push down projection. Okay, projection push down. Then I can see that okay, this is my data, and but instead why to sort this entire data, because I'm only interested in the lighter shaded part, right? So what I can do, I can before going to do sorting, I can reduce the data further by applying the filter. Once the filtration is done, I can have my further reduced data, and this data is ready for the sorting, because that is ideally part of the data that I'm interested to perform the sorting on. Now apply the sorting, find the column and find the top two. This is the way, by applying kind of projection push down and predicate push down, you can ideally optimize the data flow. And this is a very important execution order. Following that in your large scale data analysis, you can definitely make sure a lot of benefit from the execution time and the memory. So we'll understand this with some demo, with some example, real example in upcoming slides. Now with that, let's understand what FireDucks is and why to explore this library. So the first thing, the FireDucks is a DataFrame library, high performance compiler accelerated DataFrame library. Why it is called so? Basically, the ducks is it's just a name of the animal because all the DataFrame libraries there, like the pandas, boulders, they are named after an animal. So we just thought of first of all we thought of DAX, some DataFrame accelerator, but DAX is already a name that time, so we thought of naming it as a ducks. So it doesn't have any link with the DuckDB for information. But the Fire has a meaning. Fire is from the flexible IR engine. What is IR is something called intermediate representation. That is the backbone of the FireDucks JIT compilation. So what FireDucks do is it's lazy execution, not like Pandas, like you ask and it do. Instead, you ask and it creates some instruction. For example, you ask it to do sorting. Instead of sorting, it will just create, okay, you ask me to do sort on this data on this column. Perfect. Then you ask it to do please filter based on this condition. It will just create an instruction without any calculation or like computation. Just create an instruction followed by a projection instruction and followed by a slicing instruction. Just some instruction will be generated. So if you measure the execution time for this part, you will see that it's executed blink of the eyes because it does nothing but the creating the instruction. Now you can tell me like when this instruction will be executed. These are the instructions that will be automatically triggered by some of your action on the result. For example, when you want the result to be printed, when you want the result to be dumped in a file by 2CSV to Barclay kind of operation, when you apply some kind of aggregation on this result, for example, finding some maximum minimum value or something. So that is the time by when this kind of expression will be automatically triggered and it will be executed with some compilation related optimization. Now let's say like I want to print the result. So that is the time the compiler will be activated and it will try to figure out the instruction associated with the result. And what are the instruction? It will say that, okay, I want to find the top two based on E column. So based on the filtration on B column, based on the sorting on the A column. This is how the compiler understand, okay, I have this data, but I'm only interested in A, B and E column. So it will add a new instruction to project only the target columns of A, B and E before doing the further operation, such that it can reduce the data in the horizontal direction first. Then it will figure, okay, you want to do sort, then you want to do filter. That means you're only interested to perform sorting on a selective set of row. It can do some interchange of the instruction. It can do the filter first, then it can do the sort, and rest of the operation will remain as it is. This way the compiler will optimize the generated IR. Once the optimized IR is generated, it can be translated to another Pandas version. For example, if you consider it's a Pandas program, it can be something like project ABE, filter based on this condition, perform the sorting, project the column and take the top two. Now this can be a Pandas program, this can be a C++ API call, this can be any other library call of your interest. Because this IR is quite flexible, it can be translated to any other DataFrame library or any other method call. For your reference, I just ported it to Pandas to understand it better. So that is why write one query, use this design and it can execute anywhere of your target choice. So we have developed this multi-core kernel in C++ where we use the multithreaded and other high-performance related stuff like effective utilization of the caches, the vectorization and other related stuff, so that not only the results but also it can do much faster when just comparing the kernel operations like the only filter, only join, only group by itself will be faster because of the careful implementation of the algorithm. So again, I'll be talking about these in details in the benchmarking slides. So now why you should be understanding or you should be interested in exploring this library, because of the first thing, Pandas doesn't offer you optimization, but FireDucks is lazy. So because of the lazy, it can do just in-time optimization for you. If you have a good system with multiple core available, like distribute, it can parallelize the workload, not distribute, parallelize the workload among the multiple threads. So that will result in much faster data analysis. If you work in the cloud, you will experience less cloud cost. And of course, it will run much faster. So it will attribute to less carbon dioxide. But the most important thing is if Pandas, that's fine. You don't need to understand. You don't need to learn a new library, new data frame library. So when the technology like AI and these kind of LLM things is progressing so far, it's better to learn a new technology than to learn a new library, right? So just Pandas because all of us usually start from Pandas. So knowing Pandas is sufficient, but the challenges associated with Pandas can be addressed by FireDucks automatically. Now the question is, does it handle any kind of Pandas application? Yes, it does handle any kind of Pandas application. Not only Pandas application, but also the library that expect you to provide the Pandas data from, for example, Seaborn, Matplotlib, scikit-learn, imbalance, category encoders, all the library that expect you to import the Pandas data frame, you can provide a FireDucks data frame and it can work seamlessly with those as well. So no extra learning, no code modification, you can experience much better performance benefit when switching from Pandas to FireDucks. Now let's understand some kind of demo with this. So here in this example, I am using some kind of Bitcoin data of the last 3 to 5 years, and it is trying to perform some moving average. Just load the data, creating a window and perform the mean average calculation and plot the result. So the code is same in both the left and right side. The only difference is in the import. So left side is importing pandas and the right side is importing firetest.pandas. That is the only change. But if you see in the execution time, you can see that pandas takes around 4.06, whereas firetest can complete it within 275 milliseconds. So this simple code, no modification, you can experience 15 times speeder. So that is some kind of quick demo. I'll be talking about another demo, another thing in upcoming slides for sure. Okay, so with that, let me explain you the usage of FireDucks. So first of all, FireDucks is currently available for Linux only. So if you're from the Windows or Mac user, so at this moment, probably you can consider using Google Colab or the platform that support Linux. For Windows, definitely you can try WSL because it can work with WSL. And the supported Pythons are from 3.9 to 3.12. So if you can satisfy these two conditions, you can install it using pip, and you can use, instead of import FireDucks pandas, and that will be sufficient to execute your existing program using FireDucks and optimize it. Now, how about zero code modification? If you are using program that is importing pandas and it is importing other modules, all those modules might in turn importing pandas as well. So do you need to replace all this import by yourself? No. There is monkey passing thing. So when executing the program using the Python command, just pass -o option followed by FireDucks pandas. It can automatically replace all the pandas with FireDucks pandas, and it can do the optimization for you without any code modification. For notebook like platform, the same thing. Your rest of the notebook can be same. Just on top of import pandas, you can add this extension module, and it can automatically replace the pandas with FireDucks pandas, and you can experience the benefit out of it. So now let's understand what is the challenge with seamless integration with pandas. Like, of course, FireDucks is something that I'm talking about, but there are other high performance pandas alternatives as well, right? Like DuckDB, Polars, Dask. These are the library that try to achieve the same kind of problem. Like, because pandas is slow, so they have their own version of optimization that can address the slow performance of pandas. But the major challenge comes with the compatibility with pandas. Like, if you want to use those library, you have to learn that library first, because either they are not compatible or they are not fully compatible. So you need to understand the library first, and sometimes it may happen that because pandas is full of features, right? But those library might not offer that feature, so you need to convert the library to pandas using from pandas and to pandas mechanism. And when comparing the result and the performance, once your complete program can be migrated, you can compare the performances or test the results. So that are the challenges associated with it. So whether you want to take that effort for that cost optimization, so there is always a cost performance thing in your mind. So yeah, you have options like Modin, Dask, Vex, but they are ideally for the multi-node environment. There is something called Polars that is for the single node environment, that is super fast, but it is not much compatible with pandas. So if you want to use Polars, probably you need to understand the library in the very first place. That is where FireDucks can help you, like being it highly compatible with pandas, no code modification, no node learning associated with it, and you can experience the single node speed up if you're working on the data and that can be fit into memory, you can work with FireDucks. Of course, it provides optimizations. It may happen that although you have a bigger data, but you're not interested in every part of the data, it can do the optimization for you, and it can just selectively load the target columns and rows such that it can do a lot of justice with your like limited set of resources, the memory and the number of cores. Let's see like how seamless integration is possible with Pandas. For example, this is a demo notebook. You can consider the actual notebook from this link, but let's understand what it's trying to do. It is trying to load parking data from NYC parking violation. After the data loading is done, it is trying to perform a query where it is trying to see which parking violation is the most commonly committed by vehicles from various United States. Because of it, in order to execute the query, it do some group by head and sorting kind of stuff. So the major code is entirely written in Pandas, so there is nothing that you can identify new. So everything is written in Pandas. Now simply I executed the same program using Python followed by the program name. So you can see that the data loading take around 2.4 and the query one takes around 2.8 seconds. Overall, it takes around 5.3 seconds. But in order to execute the same program with FireDucks, no code change, just add hyphen in FireDucks.pandas and it can be done much faster, like almost 8 times faster. But the data loading as well as the query processing can be done much faster when we're switching to Pandas to FireDucks, just by adding a program option, nothing else. So that is how it is very like easy to integrate. Once you download it, it can be integrated to any Pandas application and you can experience the speed up. So definitely you can try the notebook for further exploration. So now let's consider the optimizing features that is available in FireDucks. So this is the design of FireDucks. Like it looks like a Pandas program because we mock all the API that is written, all the user interface in a Pandas like interface, but down the line everything is written in C++. The instruction is optimized by the compiler. So what happens in Pandas is like you write the program and it executes it right after you call it, right? But in case of FireDucks, as I explained, that it creates some kind of instructions, and those instructions will be optimized by the compiler, and the optimized instruction will be converted by a system call, and then it will be executed by the multiple code that is available in your system. So all the available code in your system will be effectively used. The system cache will be effectively used, the vectorization will be effectively used. So because of this, you can experience much faster speed up when using FireDucks. So now what is the offering from these two layers? So first of all, there is a compiler. So definitely you can expect compiler specific optimization like common sub expression elimination, date code elimination kind of stuff. So you can expect domain specific optimization like predicate push down, projection push down that I talked about so far. You can expect some Pandas specific tuning here as well. So I'll be talking about it in upcoming slides. Now, what about the second most layer, that is the backend? The backend is multi-threaded first of all. So if you have a very good system with multiple threads available, you can experience much throughput out of that. It can take good use of the memory because it is backed by Apache Paro memory, the major data structure backed by Apache Arrow. So you can have compact usage of the memory as well. And all the kernels like join, group by, filter, drop in, everything is written from scratch by our own patented algorithms. So this kernel operation itself is much faster when comparing to Pandas or other high performance Pandas alternatives. We'll be experiencing it in upcoming slide for sure. So yes, so let's understand what is compiler specific optimization. I took this example from one of the Kaggle notebook that I recently noticed. Like you can see that here df time is a column of string type. So since it is string type and the person wants to perform some group by based on the year and month, he wants to find the average sales. So what he does is he perform the string column to date time in order to extract the year field and the month field and do the stuff. But as you can understand, the toDateTime itself is a complex operation because it tries to parse a string to convert it to toDateTime. So if you do the same operation, the same data more than once, it is going to cost you when your data is growing in size. So ideally what is better is you can just compute it once, put it in some placeholder and use it wherever you need it. So this is something a basic programming know-how. But because FireDucks uses a compiler and the compiler can identify this kind of common expression. So, well, I already have do it. So because compiler will create an instruction for that. Again, it will create an instruction for this. And then it will say, I already have created the instruction, so let me use that and wherever it is referred instead of creating a new instruction. This kind of optimization is possible by FireDucks. So this kind of CAC, common service elimination optimization benefit you can definitely get from FireDucks. Another thing is something called date code elimination. So for example, this is a piece of function, so where it is trying to merge X table with the Y table, and after merging it is trying to do the sorting operation. After sorting, it is doing the group by, but the group by using the merged variable, not the sorted variable, right? So in the entire function, this is the line that is used but have never referenced. So when you use pandas like eager execution model, it will be executed because the sorting is, you ask it to sort, right? But FireDucks can identify, okay, you asked me to do, that is fine. I create an instruction, but you never used it, so I'll not execute the instruction. I will eliminate that date code out of my execution graph, right? So this kind of date code elimination is possible when you switch to FireDucks from Pandas. If you want to explore more, so you can definitely read the article that explored about this kind of compiler specific optimization details. Yes. Now let's talk about some domain specific optimization that we discussed so far, like projection push down and predicate push down. For that, I have taken one sample query from TPCH benchmark. The query Q3 will retrieve the 10 unshipped orders with the highest value. Ideally, it was written in SQL. First, let's convert it to pandas and see what it does. So if you carefully notice the query, it doesn't perform any kind of best practices that we understand, like kind of reduction of the data in the row direction, the column direction. It doesn't do anything as such. It loads the entire data from 3 tables, customer, orders, and line item. After loading the data, it just join them to create a bigger table such that it can perform rest of the operation like filtration and group by rest of the stuff as per the demand of the query. So when we execute this query using Python, using pandas, that pandas took around 203 seconds and the memory consumption was around 60 GB for the scale factor 10. But when we execute the same program using FireDucks, just by adding this plugin, it can be finished within 4.24 seconds and the memory consumption was around 3.3 GB. Yes, because although we have written it without consideration of the optimization, FireDucks compiler will do it for you. It can figure out all those stuff like the reduction of the data in the horizontal direction and the vertical direction and apply it automatically, because of which you can experience much speed up from this kind of program that doesn't take care of the optimization. In order to understand that, let's manually optimize this program. So what is the best practices? First of all, the practice is to, instead of operating on the entire data, reduce the data in the columnar direction, right? In the vertical direction. So by carefully observing the query, you can see that we only need these 2 columns from the customer table. Also, there are 8 columns. We only need these 4 columns from the line item. Although there are 16 columns, we only need these 4 columns from the order table. Although there are 9 columns. So instead of loading the entire data, I will only load these selective columns. Then I only need some particular rows from these tables because of the filter operation. So I will filter all the target tables based on the given condition. Then I will just join the tables to the group by and aggregate and the sorting operation. Now when I execute the same optimized query in pandas, it becomes 13 seconds. So 203 seconds can be optimized to 13 seconds with this manual optimization, and the memory can also be reduced from 60 GB to 5.5 GB even when you use pandas effectively. But when you see the FireDucks, even though you try Q3 and opt Q3, manual optimization is present or it is absent, doesn't matter. It can execute with the same speed and with the same memory comment, because if you do it manual optimization, fair enough. When you cannot do it, FireDucks can do it for you. So you can rely for such optimization on FireDucks definitely. Now let's understand one of the parameter tuning that is possible in FireDucks, not FireDucks actually. First of all, what is the parameter tuning that you can do in pandas, then how FireDucks can take care of that. So in order to understand that, let's consider that this query where it is trying to perform group by on the department column of the employee table. Followed by that, it is calculating the average salary and sorting the salary based on the descending order, right? So what will happen? It will create the group. So IT group, admin group, finance group, corporate and sales group, and it will perform the average of each group. So that is ideally the group by operations, but there is a hidden cost associated with it, and the cost is the group by is by default has a parameter called short, and the value is true. What the meaning of the short parameter is, it is trying to sort the result of the group by based on the key column. Here the key is the department. So it will not only compute the group by aggregation but also sort the result by the key column. So admin will come first, followed by corporate, finance, IT and sales, sorted by the department. But in your query, you don't need this sorting to happen. Instead, you want the result to be sorted by the salary, by the value column in descending order. So again, because you ask the pandas to do so, it will do it. It will sort the result by the descending order when it will encounter the short values. What you can expect that this is the step that is taking place because of this default parameter of group by, but this is the redundant step. It can be avoided. Even if we don't perform this step, it doesn't impact my result. So this is a redundant step. How we can avoid it? We can simply impute the short equals to false parameter for this case. And if we apply this, pandas will skip that step and will get much better performance. Now, this data have very less cardinality, only 5 groups, but when you have a very high cardinality in your data, many groups are present, you can expect that this will give you much more performance in terms of speed up. Like when I try with 100 million samples with high cardinality, I expect like without short equals to false, it was taking 50 seconds, and with short equals to false, it 30 seconds. The short itself has a lot of like almost like more than 50% contribution for this query. So this is something called parameter tuning, and because of the compiler in FireDucks, it can detect that after group by you want to sort the result. So the default sorting in the group by is not needed, and FireDucks can automatically impute such parameter by making it false, such that you can avoid this kind of performance cost which is hidden in pandas. So that is again one of the offering when you will be using FireDucks. Now with that, let me talk about some benchmarks. So this is a very popular benchmark called DB benchmark, where they have written several around 10 queries of different complexity of the data with different cardinality and size for the join and group by operations. So when you see the comparison table, of course pandas is slow, so that is why it is from the very bottom, but other high performance alternative of pandas like polars, DuckDB and all, you can see the FireDucks is something that can outperform all the other library as well, and it is something around the top. Great. So now if we talk about some general overview of this popular library, so I can have this kind of image at my mind. So in terms of pandas compatibility and single node performance, if I compare this library, so you can see DuckDB is a library that DuckDB and polars are the library that can work better on single node performance, whereas Spark, Dusk, Modin are the library that works better on the multi-node computation environment because they are target for the multi-node. In terms of pandas compatibility, DuckDB is very less compatible because it is for the SQL API, where polars is not that compatible, although it somewhat look alike interface with pandas. But FireDucks and Modin, these are the library that are fully compatible with like pandas kind of thing. And of course, Rapids has its own QDF. That is for GPU, although that is another different story. But Rapids is again compatible with pandas, providing good performance. But since it is for the GPU platform, so it is something different than all these libraries at this moment. All the polars has its own GPU version available, and so for the FireDucks that we are currently working on. Now, if we talk about the TPCH, that is one of the popular benchmark. In this demo, I have used query 3 only, but actually there is 22 query, and when we compare the 22 queries for against pandas and other high performance alternative like polars and Modin, we can see that Modin was working not that good, like somewhat similar to pandas, but polars was quite faster. It was around 57 times faster when performing the processing stuff. But FireDucks can outperform the average around 125 times. So it can work much faster without even modifying a piece of existing pandas code. And if we compare the scalability of the library in terms of DPCH framework also, we can see that the Polars, DuckDB, FireDucks are the library that offer multi-threading, where Pandas works same. Even though we increase the number of cores, there is no visible change in terms of performance in Pandas, even if we include the IO or exclude the IO. But in case of DuckDB and FireDucks, that shows somewhat good scalability when we increase the number of threads during the execution. Polars is again doing scalability, but those after some extent the polars doesn't show that much of scalability when at least for the TPC's benchmark. Till 8 cores it was fine, but after 8 cores the scalability was something that was not quite good when we compared the performance with polars to the TPCH. So here are some resources on FireDucks. If you want to know more about it, explore the articles written for FireDucks and other libraries, we can check out this website that is there. We can follow on us on Twitter where we publish the information related to articles, the new development, the new release, etc. If you find any issue and want to report back to us, you can refer to the GitHub page. You can definitely connect us over the Slack channel. We'd be happy to welcome you there and collaborate directly with you if you have any questions. So with that, let me conclude my talk. Thank you once again for listening to me. And I hope you enjoyed the talk. The key insight that I talked about in best practices and how Pandas can help you to improve your journey with Pandas. So enjoy green computing and explore FireDucks. If you have any questions, I understand that this is something online, so probably I cannot make it interactive this time. But if you have any questions, you can connect me over the LinkedIn or any other preferred social media network, or you can definitely get in touch with the Slack channel and other media. I'd be happy to help you in optimizing whatever problems you may have with Pandas and discuss some kind of collaboration if you are interested with. Yes, with that, I'm concluding my talk. Thank you very much once again for listening to me till this end. I hope you enjoy the rest of the presentation as well. Happy collaboration, happy learning. Thank you so much.